Good. In our last video, we started images formed by curved mirrors, and we were on concave mirrors, where I placed the object beyond C, that's the center of curvature. And we saw that the image was formed between center of curvature and then the principal focus. Now, let's place the object also at C. If I draw my concave mirror, we draw it this way. Let me draw the principal axis, the center of curvature, P, then principal focus, F. Now, we are going to push the object at C. So you can say object at C. That means object at center of curvature. Object at center of curvature. We follow the same rules. Rays parallel to the principal axis. Reflect through the principal focus. And rays passing through the principal focus also reflect parallel to the principal axis. Reflect parallel to the principal axis. Let me adjust my drawing. And you see that the image will also be formed exactly at C. The image will be also formed at C. If you draw this on a graph sheet, you get everything clear. This is just a freehand sketch. Okay. We are still on images formed by concave or converging mirrors. This time round, let's place the object between C and then F. If I draw my concave mirror, pull, center of curvature, principal focus. And if I place my object between C and then F, center of curvature and then principal focus, we follow the same rule. Rays parallel to the principal axis, reflect through the principal focus. And some of the rays will also pass through the principal focus, will also reflect parallel to the principal axis. The image will be formed somewhere here, inverted, and it will always be larger than the object. The image will be produced beyond C inverted and is larger than the object. And the image formed is also rare image. Again, when you say, let's see, object at F. Object at F. I draw my concave mirror. I draw my principal axis. The pool, center of curvature, and if this is the principal focus. This time round, I place my object O at F. Then you follow the same rule. Raise parallel to the principal axis or reflect through the principal focus. And when the ray also incident at P, it will also reflect, making the same angle as the angle of incidence here. There's a theta 1, and here will be theta 2. The angle will always be the same. And then some of the rays will also pass through the center of curvature hitting the mirror, and they are going to reflect back along the same path. You see that none of the rays intersect. They are going to intersect at infinity, and at this particular point we say that the image is formed at infinity. The image will be produced at infinity. The next one, let's also push the object between F and then P. Object between principal focus and the pool. O between F and P. Let's draw our concave mirror. Draw a concave mirror. I draw my principal axis P, and here in the center of curvature, we call the principal focus, capital F. This time round, the object is now between F and then P. We follow the same trend, raise parallel to the principal axis. Let's go over some of the rays will pass through the center of curvature. Draw that one first. Hitting the mirror will reflect along the same path. And for the principle of reversibility of light, the path of light rays are reversible. Half of life is reversible. Let me put it like this. And then you can also see some of the rays also pass through parallel to the principal axis. We're going to reflect through the principal focus like this. So they will reflect through the principal focus. this one, for the principle of reversibility of light. Half of light rays are said to be reversible. And for this one, we are going to have a virtual image formed at the other side of the mirror. And the image will be upright, larger than the object. And it is virtual. The image formed will be virtual, larger than the object, and it is always upright. So these are the images produced by concave mirrors. When we meet again in class, I will bring some concave mirrors and then you observe it rare, how these images are formed. Now let's also talk about convex mirror. Convex mirror. And convex mirror, I draw my convex mirror like this, in which we coat the inner surface so that the shiny surface is outside. Then let's draw our principal axis. Passing through the pool. Here, the center of curvature will be somewhere here, because that's the center from which the mirror is forming part from the sphere. And the principal focus will also be somewhere here. If we place an object, see somewhere at this side. Object here. Notice that rays parallel to the principal axis are going to reflect through the principal focus. But this time around it will be virtual. Virtual. Virtually, and the actual one will be reflected in this direction. And again, some of the rays also pass through the center of curvature. Center of curvature. Can also be a virtual ray, then a very small image will be produced this side. That is where the two virtual rays intersect. Smaller image will be formed there. And a typical example of convex mirror is driving mirror. So you observe that driving mirrors produce small upright images. And it depends on the distance of objects from the mirror. So that is, the image form will be virtual, and then it is also upright, smaller than the object. Always the image produced by convex mirrors are smaller than that of the object. And what I want you to do is to learn how these images are produced by using your graph. Use graph book, and you can use your compacts to draw the curved mirror very neat, and with the help of your rule you can understand the images very, very well. Because on the graph sheet you can draw your horizontal lines and then your vertical lines, as well as the principal axis, and you can always divide the principal focus, that is the distance between the principal focus and the radius of curvature. With the help of the graph sheet, you can do them very well, and you can always produce a very neat diagram when you are learning curved mirrors. Images formed by convex mirrors are always the same, unlike concave, in which the image keeps on varying, changing as you begin to send the object more closer to the mirror. Here, whether it is far away or closer, only the size will begin to change, but it will produce the same virtual and upright image. And I told you, convex mirror, an example of convex mirror is driving mirror. Driving mirror. I will show you some of these convex mirrors in our next meeting in class. And until we meet again next week, you can call my number 020-8717-604, or you can email me through my email yahoo.com. Or you can contact me direct through my email on Wednesday coming. You can meet me online or at the internet study platform on Tuesday let's meet on 4 o'clock p.m. to 6 o'clock p.m. I will also attach some notes on curved mirrors there, or you can also study curved mirrors through internet, or you can also Google and get more information on all what we have learned so far. Thank you very much.